of our Starknet Basecamp. This Basecamp is probably brought to you by the Starknet Foundation. Session 2, we are going to look at Starknet architecture and account abstraction. What does that entail? We are going to look at the inner chamber of Starknet. So in that, we are looking at the architecture. My name is Bosa Joseph, and yeah, I've been in the space for some time as a blockchain developer, and as well I'm doing this advocacy for Starknet. So I'm building a startup called SwiftRamp. So you can give me a follow on X. Yeah, so it's at SwiftRamp. That's my X handle. The breakdown of our session today. The first section we are going to look at is Starknet architecture. Like how is Starknet built up? Yeah, so that's what we are going to look at. And we are going to use an analogy which is very common. So there is this analogy. It's a good example. I just want you to take an example of how a bar works. What happens from the moment you step in till you leave. So I just want to use that analogy to explain to us how Starknet processes everything from the point a transaction enters and to the point that a transaction is to the point that a block is being settled on Ethereum as an L1. Remember, I said Starknet is an L2, yeah. So it scales Ethereum. So Ethereum is the L1, and this Ethereum is the base layer. So everything that happens, every transaction that takes place, yeah, it's supposed to be settled on Ethereum. So we are using the bar analogy to kind of understand what is running behind the scenes. Yeah, in many bars or any restaurant, or a bar, when someone gets into the bar, or maybe they are attempting, yeah, to enter a bar, or maybe I've just used the bar in this example, but you can relate it to other examples, but I just chose a bar. So imagine you're entering into a bar and you are just attempting to enter. Maybe there is a function at the bar, there is something going on at the bar. They are usually guys, those big guys are called bouncers, yeah. They're usually at the entrance, yeah. And or we can relate it to security checkpoints, yeah. They're usually security checkpoints, and the security checkpoints are supposed to just verify, that you haven't come in with anything harmful to your neighbors, and yeah, they're supposed to verify literally that when you get inside the bar or the restaurant, that you're not compromising the security of others. So after passing the security checkpoint, you are accepted to sit. That means you have been verified that you are secure. Yeah, you've been verified that you are not going to harm others. Yeah, you are from a point where you've now been accepted to use the bar. A waiter reaches out to you. I'm going to use an example whereby to bring this out clearly, I'm going to use an analogy where you are using cashless payments. Yeah. So maybe at this specific bar or restaurant, they do you first pay to book whatever you are gonna have, or maybe you have come for a drink, maybe you've come for a pizza. So they're like, no, first pay, and then when you pay, that means the money is sent to their probably their central payment system. So when you sit, and then the waiter has probably brought you maybe a menu, then you've chosen what you want to be served, then you've made a payment. Yeah, after making a payment, then so the waiter is you call the waiter and you're like, let me show you, this is my proof of payment, this is what I've ordered. The waiter verifies. Yeah, so most times in some restaurants, at least those I've gone to, how the system works is that the waiter generates some small cheat with whatever you've ordered, and they transfer this. They transfer this. They transfer this to whoever is preparing. Yeah, and then there's something which is being given to you. I'll use an example. For example, use an example of Food Hub. There is something which is being given to as a form of waiting. That this is your number. You've paid, and you are in the queue. They're processing your order. It alerts you when your order is ready. Yeah, and you can be able to see it on the screen. So then at the end of the day, when this restaurant, so after you've placed your order and each and other customer does the same, so on close of business, at the end of the day, the manager balances. Yeah, you know that these are the customers who came today, and these are the stores were able to make. It balances everything. So I'm just using this analogy to kind of explain how Starknet works. Yeah, so we're gonna see that Starknet. This is just sort of like a transaction life cycle, yeah, of Starknet. So it has a mempool, it has a sequencer, it has a prover, and it has a verifier. A mempool is a pool of transactions. Yeah, probably your DApp is maybe a social media DApp. Maybe you are having users sending messages, some users liking, some are replying. Yeah, and I recall telling us that each of this is an activity. Yeah, and then I recall telling us that just like in the conventional web 2 system, when you made a post request, that's if now I'm using an example of our DApp, and maybe it's a social media application. Yeah. So if at all you made a post request, maybe you are chatting with your friend. Yeah. So, and I recall telling us in the previous session that a post request, every activity that happens is a transaction. Yeah. And the post request has a cost implication. Yeah, there is gas fees to be spent on the blockchain. Yeah, so a GET request does not add a block. It's a post request which adds a block on the blockchain. Yeah, and whenever every block is to be added, there is a cost implication in terms of gas fees which are to be paid. Yeah, so for example, now you have your transactions. Yeah, maybe they can be 10 transactions. Yeah? So all these are sent in the mempool. The mempool, I want us to understand it as, so remember I told us that the blockchain has to ensure nodes have to the validators of the blockchain ensure that there is no malicious activity going on the blockchain. And I remember telling us that there are some dividends these validators receive from maintaining the blockchain from any security threats. Yes. So now in this case, so once a transaction is sent, yeah, once it's sent to the sequencer, so this is a mempool. The mempool is having, now if I told them to use the bouncer analogy, one person is being checked, yeah, by the bouncer, yeah, and once they are verified, yeah, that this person does not have any harmful weapon, yeah, they are letting. So these are the mempools. So in a mempool, the mempool is where now all these transactions are coming from, probably from your smart contract. Because remember, this when you write your DApp, yeah, it has a smart contract is like your back end, then it has a front end. So the component of your application for talking to the blockchain is a smart contract. Yeah. So the mempool is having smart contracts. Yeah. So now these smart contracts are being sent to the sequencer, and all is done in the sequencer. What happens there is validation and ordering. Yeah. So in the sequencer, yeah, there is just ordering and then validation. So in case the some malicious attack which is being found out, maybe in a smart contract, yeah, and maybe there's it's not valid, maybe there's something wrong, yeah, the sequencer takes back the smart contract to the mempool. Yeah. So the role of a sequencer, I just want us to understand that just using like the bar analogy, yeah. So one person after the other, you can sit down, probably you start maybe the first person has started at table 1, the second person has started at table 2, the third person has started on table 3. So the sequencer receives all these smart contracts and it handles them sequentially. Yeah. And so its role is to validate and then order. Yeah. So if at all it's being realized, yeah, if at all it's being realized that the smart contract has an issue, it's being sent back into the mempool. Yeah. So from the sequencer, we go to what is called a prover. Now the prover in this case is just like to, so you've paid, yeah, and so in using the bar analogy, you've made a payment, yeah. So after making a payment, you can just show to, maybe you've paid using MTN mobile money, probably you've paid to the restaurant's merchant code, yeah. So after paying, you just show this person who's handling your order, who, okay, maybe like the waiter or the waitress, that look here, so after paying, there is a digital, of course, proof of payment which is being generated, that yeah, you've paid this amount of money and you've shown this to your waitress. So that's the same thing here. This is the same thing here, what as the prover does. Yeah. So after this smart contract has gotten into the sequencer and then it has been validated, and then it has been, of course, the sequencer, as you hear, it works sequentially. So the first one is handled first. So then it's taken to the prover, and then a prover is just like showing, you're just proving to the person serving you that I've made the payment, he is my proof. So this prover, just like in this bar analogy, that after you've made the payment, now probably the waitress sends this, maybe generates that, no, this order has been made, and then she takes it to the part of the restaurant which is responsible for making the meals. Probably it's a meal or it's a drink, and then so they're showing these people, whoever is in charge of making the meals, that this person wants this and this and this. So that's from the prover. Then that's the verifier which is being generated. Yeah. Now I want us to understand. In our previous session, I talked about that the power of Starknet is in that it does not handle one block at a time. Yeah, it does not handle one block at a time. So it handles blocks as a whole. Yeah, just imagine if at all every transaction, which is a block, that is every block which is being added on the chain. Yeah, just imagine the time needed. Just imagine you have 1,000 transactions, and remember every transaction adds a block. Yeah, now just imagine you have to verify each block independently. Yeah, so that will take a lot of time. So the power of Starknet is in its ability to handle various transactions, yeah, to verify many blocks at once. So it doesn't need to individually verify each single block. So I will use again the analogy of the bar, that at the end of the day, yeah, at the end of the day, since every transaction was added into the system, so the manager, yeah, going on probably the central management system, yeah, he probably the system is configured in such a way that it can show how much they have made in a day, and then it can show these were expenses. Yeah. So I want us to understand that as that. And then, so this is the transaction life cycle. Then I'm gonna explain this in this current slide. I've tried to compare now using a table format where the bar process versus the Starknet components and what each does, the functionalities of each. Yeah. So the bouncer checks checks the safety, whether you are secure, whether you don't have any harmful weapon. Then maybe for some people, for example, for cases of bars, there are some age brackets which are not accepted in bars. Yeah. So after maybe the bouncer has verified that this person right here is 18 years, and maybe they've checked that you don't have any harmful weapon. Yeah, so that's the same thing the mempool does. Yeah, so the role of the mempool is to filter out this and send it to the sequencer. So I want us to understand it. So the mempool filters out, yeah, and sends it to the sequencer. So it filters the transactions. So the waiter processes order and payments. The waiter processes orders and payments. So so I want us to understand that what is happening in the sequencer is basically ordering these blocks, yeah, and then executing them by sending them to the prover. Yeah. So what is happening in the sequencer? We have blocks which are coming from the mempool, yeah, and then they're being ordered, yeah, just like in the bar analogy. That, for example, if I told you reached the restaurant at maybe a person who reached at 4 and then for 4 p.m. and then for you reached at 7 p.m. Yeah, definitely the person who reached early at 4 p.m. will be sorted before the order of the person who reached at 4 p.m. will be processed first before the person who reached at 7 p.m. or 8 p.m. That's the same thing that happens in the sequencer. Yeah, to execute the transaction, ordering takes place first, and then executing the transactions by building the blocks. So then after the sequencer, it goes down to the prover. Yeah, at the prover is where a proof of transaction, it generates a proof of transaction. Yeah, remember guys, as in our previous session, was when we were introducing Starknet, we said it works on proofs. The whole notion of Starknet, how it works is that you prove first before you execute. Yeah, so that's the whole notion of Starknet. Prove first before you execute. Yeah, so every time you prove first, that means you can execute multiple transactions at the same time, compared to executing first then proving. Yeah, so I don't know whether you get that. So in case there is something that you need clarity on, you can just put it in the group chat and then I'll be able to answer it, maybe now or maybe after the session. So from the sequencer, we have the prover. So the prover generates the proof of transaction, just like the cashier has printed the receipt, and this receipt has been taken to whoever handles the receipts, or maybe the people who are responsible for preparing the meal. Maybe you need to show them that this is the what this receipt, this order, the person needs this. Yeah, so I want us to relate it to how a prover works. So the prover, its whole role is to generate a proof of transaction. So then the last bit of it, so the manager, just like in the bar analogy, that the manager verifies all the records at the end of the day. Yeah, the manager has to ensure that in this day, these were the orders that we got, and this is how much we made. Yeah. So now the verifier, that's the same thing it does. So it finalizes transactions and settles them on Ethereum. As our remember, guys, when in the previous session when I was talking about the blockchain trilemma, in that Ethereum decided to basically focus on being a settlement layer as an L1. So everything that happens, everything that happens in all L2s has to be settled down on an L1, which is Ethereum in this case. So all transactions have taken place in this scenario, and the verification, the settlement, yeah, is being finalized on the Ethereum blockchain as an L1. So any questions about that before I proceed? Guys, any questions? Let me see someone saying in the chat. Yeah, someone is asking here, how does L1 and L2 work together? Someone is asking, how does L1 and L2 work together? Yeah, how does L1 and L2 work together? So I want us to understand this as, let me try to put it very clear to us that, so I want us to understand the Ethereum blockchain as follows. I didn't want to repeat this because we talked about it in the previous session. Let me try to clear it once and for all. So I want us to understand that you just imagine a case where Ethereum, yeah, remember one of the naturally the blockchain is slow because you know that every node is talking to the other node, yeah, and because every node has to learn from whatever is taking place in each and every node, so somehow it's because of this decentralization nature, it makes it slow, yeah, makes it so slow. And I want you to just imagine a scenario where you are having 1,000 transactions happening maybe per minute, and all these 1,000 transactions, yeah, so when they reached as I talked in the previous session, that the blockchain trilemma entails security. So blockchain, for a blockchain to be perfect, it's supposed to handle security, decentralization, and scalability. So the bit of it where many transactions are to be handled by in time is the scalability bit of it. But then remember, so now the flow, the loophole which was realized is that Ethereum as a mother layer could not handle all these three things at the same time. Yeah. Now all in all, what L2s like Starknet, yeah, every other L2, all they are doing is to handle one thing and do it better, yeah, so that now Ethereum, yeah, it now only remains as a settlement layer. So now that's what generally Starknet is doing, yeah. So Starknet as an L2, all it's doing is to offload some of these transactions before they are being settled on Ethereum. So in that I mean that there is no need for all these transactions, yeah, to happen, yeah, on chain on Ethereum, yeah. So Starknet is offloading all these loads, processing all these transactions, verifying them, and then settling them on Ethereum. Yeah, so I don't know whether that's a bit clear. Can you just give me a thumbs up in case I've tried to explain? So L2s, all they're doing, they're trying to offload Ethereum from some of the tedious tasks. For example, Starknet is offloading the processing bit of maybe these multiple blocks, and it's saving Ethereum from this burden. And then the only now bit of Ethereum has to do is that after all these transactions have been verified, yeah, Ethereum, the only thing is doing is settling them. So can you give me a thumbs up in case you grasped that? The person who was asking. Yeah, thank you. Thank you so much. Okay. So any other question at that point?
Please, can you clarify the architecture which you have just highlighted? Is it only common to Starknet, or is also common to other models of DLTs, distributed technologies?
So the model that I was sharing is only to Starknet. Yeah. So other chains, other L2s have a way they operate, but this is only Starknet as an L2. So other L2s right now, Starknet is leading in terms of scaling, in terms of how many transactions. So right now, Starknet as a chain, it's handling, it's the leading. If I'm not sure, because it has been the leading. It's the leading L2 in that is handling to handle multiple transactions at the same time. So that's why, as I recall sharing with you in our previous session, that you find that the gas fees which are incurred on maybe you built your application on Starknet, you find that the gas fees which you as the developer incurs are lower, are close actually to 10 times lower compared to other L2s. So that's the power of Starknet. The power of Starknet is in scalability. So the architecture of Starknet is not similar to the architecture of other L2s. So I'm only sharing about Starknet. So other L2s maybe zkSync or maybe so they have different other architectures. So it's different from other L2s. So I didn't know. I don't know whether I've answered you clearly. Can you just give me a
Sure.
thumbs up?
Thank you for that. Okay, just another one. Uh,
Yes, yes.
I understand. Just another one. I understand. For instance, in cybersecurity, there are governing protocols which governs different models and the like. I'm interested to know if there is also similar trends in derivatives, particularly in Starknet. For if there's any industry standards, industry protocols, which sets the framework for the.
I beg your pardon. I didn't get you properly.
Yes, I'm
Security. I didn't
asking.
get you properly. Yes,
Yes, I'm
yes.
asking. Is there any industry protocol, the industry standards, which guides how the Starknet architecture operates?
So I remember sharing you before sharing with you that before any all these chains they go through a lot of testing, yeah. And I want to also let you know that Starknet does not only so you can as well write a program which is not a blockchain program and Starknet. So you can use Starknet, the Cairo. We are gonna see that in the next slides. We are gonna see that Starknet is not only limited to the blockchain. So in case there is any industrial maybe use case that needs proving, yeah, before execution, actually the Cairo programming language is built around that. And since the Starknet blockchain, yeah, is run on the Cairo VM, and so when you're writing smart contracts, you're using a Cairo programming language. So I just want to let you know that Starknet is not only limited to blockchain, so you can use it even in other normal programs. Yeah. So and then just to clarify that before a chain comes in active usage or before it comes in active production to be used, yeah, it goes a lot of stages. Every software goes through a lot of stages. So I don't know whether Mr. Kaunda have answered you properly.
Somehow, thank you.
Yes, Joel.
Yeah, so my question is, Starknet seems to compile its own blocks. So when those blocks
Yes,
are
yes.
combined, do they now when you're joining the layer one, the Ethereum, do those blocks enter and combine into blocks existing on Ethereum, or do they form their own blocks on the Ethereum chain?
So the ultimate settlement, yeah, because Starknet is built on top of Ethereum. So after all these blocks have been verified, and then what? Yeah, Starknet runs on top of Ethereum as a blockchain. So all these L2s, the meaning of L2s means that we have an L1 which is Ethereum, and everything the ultimatum of it is brought back to the L1, which is Ethereum. So that's what, I don't know whether you get me by that. So everything that happens through all this verification and what and what. So the final thing is the settlement happens. All the blocks, they are recorded in Ethereum. Ethereum as the base layer. So I don't know, Joel, I've answered you properly.
Well, so I'm basically like trying to ask, let's say if I'm, of course, using analogies now, if I'm making, let's say,
Yes, yes.
cement block, this is which cement blocks they use for buildings.
Yes.
I'm going to get my cement, my sand, and my concrete, and I make a what? A block, you know? Yeah. And let's say that's on what? That's on Starknet, you know? But then let's say Ethereum is also having its own chain, you know? So maybe Ethereum, well, the whole thing is Ethereum has blocks and Starknet has blocks. At that point of intersection, are the blocks in Starknet going to go and enter into the blocks within Ethereum as transactions, or how does it happen at that point when they are connecting?
So I get your point. So yeah, thank you for bringing the concept of thank you for bringing out the concept of blocks. So let me just use blocks. Yeah. So let me say they are building a house. Yeah. Sometimes they are bricks which are to be used, but then when they find out that this brick is broken, yeah. So you have a pile of bricks, yeah, and then you only choose out the good ones, yeah. So the pile of bricks is in this case a mempool, yeah. So you cannot use a brick which is haphazard, which is very bad, yeah, because it will affect the stability of whatever you are building, yeah. So you get out a brick and then organize each brick onto the other. Now that brick per brick is what is happening in the sequencer. So the sequencer, all it's doing is ordering, yeah, and executing, yeah. So now in this case, maybe the execution can be that you've added the bricks one following the other, and then the execution can now be that if at all you've ordered, now that bit where they have to add sand and mortar, yeah, where they have to add sand and mortar, and then go on maybe to a next level. So I want us to get that. So referring to Starknet. So after all these blocks, everything on the blockchain, yeah. So just understand it as that the blockchain is just, and I want us to understand it that every transaction which is being added, every activity which takes place, yeah, every post request, yeah, is a transaction, and this transaction leads, when once it's being validated that it's not malicious, yeah, it leads to a block being added, yeah, and so this block goes through all this verification proving, yeah, but at that point it's not added on Ethereum, it's still in the L2, yeah. So it's the same block which is going through this whole cycle, and then the final destination of this block is when it's being added on Ethereum blockchain as the settlement layer, the L1 as the settlement layer. So it's one block, it's moving through the L2, which is Starknet. Now this block has to be verified, and it's proved, and then it's settled down, yeah, on Ethereum as an L1. So I don't know whether that's very clear to you, Joel.
Very clear, sir.
Yeah. Thank you. Any other questions? I didn't want us to leave this part before some guys can actually. So is in case guys you have any questions, you can always put it in the chat, and I can be able to answer you back to.
Yes, excuse me, sir.
Proceed.
I just have one concern to put across.
Yes.
I'm actually wondering why we have to use the. Is it what? What is it called again? Or Ethereum.
Ethereum.
Yes, Ethereum. Why do we need to use Starknet without using why don't we use Starknet directly, but we have to use Ethereum also as well?
I want us to understand there is this one thing called reinventing the wheel. You don't need to reinvent the wheel to achieve your purpose, right? So just imagine if at all every software we have was doing what for example, let me give us a simple example. So now I want us to just understand this. Just imagine every year we are building the internet again. It won't make sense. So what makes sense is making the internet better, yeah, because it's costly, it's time costly, and then it as well takes resources. So we don't have to build the wheel over and over again. We are just supposed to better the wheel, not to rebuild the wheel. So I don't know whether Starknet doesn't need to build the entire Ethereum blockchain. Yeah. So why do the best solution would be to how do we make Ethereum better rather than building from ground to up another Ethereum. So I don't know whether you get me by that. Guys, in case you have any question, feel free to just put it in the chat. I will be able to respond. Meanwhile, let us proceed. Smart contracts in Cairo in Starknet are built in the Cairo programming language, and we are going to see why not just use Solidity. Solidity has many languages I've been using Solidity, but we are going to look at why Cairo, and what is Cairo as a language. So Cairo is the programming language used to write smart contracts in Starknet. Yeah. So Cairo consists of 3 components. So Cairo has a compiler. Yeah. So just let us try to digest this. So the Cairo compiler. We are gonna look at Cairo probably in the next session. We're going to start having practical sessions. But I want to let us know that the Cairo compiler is written in the Rust programming language. Yeah. And there are some downsides of that. So because of that, Cairo has Cairo code before it's translated down, yeah, and taken as a transaction to the mempool, because I remember telling us that all these things are it's code which is compiled and then taken to the mempool and then to the sequencer. So because the Cairo compiler is not actually written in the Cairo programming language itself, so Cairo has its own virtual machine. So there is a Cairo virtual machine, and then I'm introducing this, but I'm gonna talk about them more in details in the next slide. And then there is a Cairo prover and verifier. So now let me talk about them in more details here. So this is the process of compilation. Yeah. Cairo code, how does it get down to a point where it's now a transaction which is being taken into the mempool? Yeah. So as I said in the previous slide, that the Cairo compiler is written in Rust. Yeah. So because it's written in Rust entirely and it's not written in Cairo, yeah. So it cannot be it cannot be proven instantly. So what the team at Starknet is doing, so Starkware is the team responsible for writing the technologies of the the Starknet blockchain. So the Starkware team is the one responsible for it's the one which works on the technologies. It's the one as well which works on maintaining like things like the Cairo VM, maybe any developments, the Starkware team. So the long-term solution which they're looking at is to write this right here is supposed to be compiler. Sorry, this was just a typo. I will probably rectify it in the slides. So what the long-term solution that they are doing is to write the entire compiler, yeah, in Rust. So when they write the entire compiler in Rust, that means the compilation time. Yeah, I'm going to in next slide I'm going to introduce the architecture, the the compilation journey, maybe from the point where the Cairo code is written, yeah, and to the point that it gets to be compiled down. So one of the long-term solutions they are looking at is to write the compiler. This is a typo. To write the compiler. Actually, this is a typo here. To write the compiler in Cairo, not in Rust. Yeah. Sorry, guys, about this typo. So they're trying to rewrite the compiler in Cairo and not in Rust. Yeah. But for the meantime, yeah. So the temporary solution, I've been saying that the Cairo code is compiled by the Cairo VM. Yeah, so there is a Cairo VM, and I shared that the Cairo VM is written in Rust. Yeah, so because it's written in Rust, the smart contract which you've written, yeah, remember you've written it in Cairo programming language. Yeah, so the smart contract, it's compiled, the code is compiled down, yeah, to Sierra. So what it's trying to do, because remember the VM is written in Rust, not in Cairo. So by it going through these stages, they're trying to get it to where the code can be understood by the compiler. Yeah. So it's taken through Sierra is like it's like a state representation, yeah, of of the Cairo code, and then from Sierra is taken down to Siasm is like Cairo assembly, yeah. So Cairo assembly. So because the compiler is written in Rust, yeah, and your smart contract is written in Cairo code. So to get it to a point where your smart contract, the code, Cairo code is being understood by the compiler, yeah, it's taken through Sierra, and it's taken through this. From there, it's ready to be taken to the mempool. So I don't know whether you have any question around that. I just want us to understand it as raw as it is, but Cairo code, our smart contract, which is code, is written in Cairo programming language, but our compiler is written in Rust. Yeah. So the temporary solution right now is compile it down to Sierra, yeah, and then take it to the assembly. Assembly is just like machine code before it's taken to the mempool, before it's sent down to the sequencer. So I don't know whether you understand that. Any more clarification on that, guys? You can raise it in the channel. Any more clarification needed on that? Or you can unmute and ask, or you can type it in the channel. Can you give me a thumbs up in case you're following properly? A thumbs up, guys. I know the architecture is really something so complex, and I wouldn't want us to just jump and go to something before we clearly understand it. I think we can proceed. So yeah, so Cairo as a language has design principles. So the whole notion of the Cairo programming language, yeah, I remember telling us that Cairo is not only limited. Remember, guys, languages like Solidity, yeah, they are limited to only blockchain. Yeah. So let me just give this difference between Cairo as a language and Solidity maybe. So the first difference can be that Solidity does not care about fast, maybe the low level. So Solidity, in terms of processing, Cairo, yeah, Cairo code is, because when they're writing Cairo as a programming language, we are going to see in our practical session that Cairo as a language has a lot of similarities to the Rust programming language. And we are going to see that actually, for those of us who know Rust, yeah, for those of us who know Rust, we are not going to have a hard time understanding Cairo. Yeah. So why, you may ask yourself, why is it that very many blockchains in the current times why is it that very many blockchains are shifting to the Rust programming language? I remember introducing to us that the blockchain naturally is slow in nature, and yeah, if at all you use a language which is as well known fast, yeah, that means we are going to have issues. We are going to have transactions taking a lot of time, and in that, yeah, Cairo is first of all, it's a compiled language and it's low level. Cairo is compiled and it's low level. Yeah, Cairo is a compiled language. Yeah, it's not interpreted. So I was explaining that in the current times, most blockchains are shifting to excuse me, to using low-level languages, because the blockchain by nature is slow. So if at all you don't use a compiled language like Rust, yeah, that means uh, the processor is gonna take a lot of time. Yeah, the processor, the machine itself, yeah, it's gonna take a lot of time to process this code. Yeah, so the processing time is longer for languages which are not low level compared to low level language. And I think in the previous session I talked about the difference between languages like C++ and Python. So you'll find that a language like Python needs an interpreter, so compared to a language like Rust, yeah, Rust code is compiled. So in that, it means the processing time is lower for code written in low level languages compared to higher level languages. So yeah, Cairo is compiled. So I was talking about the design principles of the Cairo programming language. Yeah. So first, mainly, so Starknet, as I remember sharing, that its power is in proving fast and then execution later. So it proves fast, yeah, and then executes later. So because Starknet is being, so the language for writing smart contracts on Starknet is Cairo programming language. So that's the design principle. Like every language has a design principle. I want us to understand that every language has a design principle. Like every time they were creating a language, there is that one thing which makes this language unique compared to the other language. Yeah. So and then I want us to understand that so this language is arithmetic in nature. Arithmetic, I mean that because the sole purpose is to generate proofs before execution. Yeah. So and Starknet as a blockchain, I want us to understand it. It comes from Starknet as a blockchain is based on ZK proofs. Yeah. And proofs are computations, cryptographic computations. So the whole how can I put this clearly? So it's proofs that I generated in the end. Yeah. So and then these proofs are computations. Yeah. Remember I've said it's based on, Starknet is a validated rollup, but as a rollup it's based on, it's a ZK It's based on the whole notion of ZK proofs. So I don't know whether you get me when I say ZK proofs. Guys, do you get me? Because I talked about this in the previous session. I introduced ZK proofs. So have you gotten something about the design principles? When I say Starknet follows the notion of prove first, execute later, I need some clarity before I proceed. Can you just give me a thumbs up at that point, guys? Agri, did you want to ask something? Guys, give me a thumbs up if at all we are at par. Okay, seems no questions at this point. So now that we have looked at the architecture, so we're gonna look at something interesting, and this is called account abstraction. Yeah. So I don't know whether many of us here, for those of us who are new to crypto, to blockchain, there is something which they call our wallet addresses. Yeah. So wallet addresses are trying to open mine here. Okay. So after you've done everything, anything, maybe you've written a smart contract, yeah, you need something to pay your gas fees with. Yeah, you need something to use to pay your gas fees, and that's where account abstraction comes in place. So if at all for Ethereum, the commonest wallet that is being used on Ethereum is called metamask. It's called metamask. For Solana, I understand they use Solfair a lot, but then for Starknet as a chain, we use Agent, the Agent wallet, and then we as well use the Braavos wallet. So these wallets are different from MetaMask in some way. Yeah. So do we all know what MetaMask is? Or do we all know what a wallet is? Let me open mine here. It's taking quite a while. Let me just open my wallet here, guys, and be able to view it. So for us to pay gas fees, remember you've written your smart contract and you have to deploy it on the blockchain. So, but you have to pay gas fees. Yeah. So let me open mine here. Just a moment. So after you've written your smart contract, you have to deploy your smart contract on a blockchain on Starknet. So but you need a way of paying gas fees, just like probably in Web 2, after you've written your application, you need to host it somewhere. Yeah. So it's something similar analogy. So this is my wallet address. You can give me a thumbs up in case you can see it. Can you give me a thumbs up, guys, in case you can see my wallet address? Because there is no money, so I'm not scared of showing it to you. Guys, can you give me a thumbs up in case we're at par? I just want to ensure that we are okay. Okay, thank you. So, thank you, guys. So this is my wallet address. Now, Starknet, I'm gonna explain this, that wallet addresses, for example, MetaMask. I don't think I have MetaMask here. Do I have it? Is different from wallet addresses used on Starknet in some way, and I'm gonna explain this. So this is how the Braavos wallet address looks like. So this is Braavos. You can see this is the Starknet symbol right there, and the difference with this is that, or its significance is that every wallet has a wallet address. So this is my wallet address right there. So I want us to understand the wallet address as an account number in the traditional banking. Yeah. So you need, since you are trying to pay gas fees, yeah, you need something you need where the money is going to be deducted from if at all you are to pay your gas fees. Yeah. So when you are after in your smart contract, you are supposed to specify, yeah, where the money is supposed to be gotten from to pay the gas fees. Yeah. And this gas fees has to be in stacks. Yeah. But with innovation, there is something which is called a paymaster. So a paymaster is help. It's just a certain technology. Okay, it's I can say how can I bring it? So paymaster is so I integrate it within my smart contract, and I can be able to pay gas fees not only limited to stacks. Yeah. So STRK is the native token of Starknet as a blockchain. So every blockchain has a token, has a native token. So for Starknet is STRK. And so what Paymaster is doing, that I don't need to pay gas fees. I'm not only limited to paying it using STRK. So in Paymaster, even though I have maybe what crypto I can pay, so that's what is happening. So this is my wallet right here. And so if at all I'm writing my smart contract, yeah, I need to copy this and add it in my smart contract to tell the contract that money is coming from this wallet address. And guys, if at all you don't have any money on the wallet address, yeah, and you probably, of course, you need to pay gas fees within the smart contract, it will fail because you don't have gas fees. Yeah. So for those of us who haven't yet installed Braavos, let me just show it to us right here. So you can install Braavos wallet by installs as a Chrome extension. So it's this right here. So then if it's not, you didn't have it, so it will tell you add to Chrome. But since I have it, I don't want to reinstall it. So it will tell you add to Chrome, then it will download. Then after downloading, you come right here to the extensions. Then you click on manage extensions, and then it will tell you to pin it. Yeah, so it will tell you to details, and then you have to pin it to the toolbar. So you pin it from here, right here. So that's where you pin it from. So, and then when you do that, you'll have your Braavos wallet, then it will tell you to, it's easy to configure it. So I don't know at that point whether we're together. Can you try installing the wallet, the Braavos wallet? And then that's a similar thing you do for agent. So Starknet uses two wallets. So it uses the Braavos, and then it as well uses the Agent X wallet. Agent X wallet extension, or you can just put Agent X wallet Chrome extension, and then it will bring you this first one right here, and then you'll do a similar thing. If at all you didn't have it, it will tell you add to Chrome. Then as well you go to manage extensions, then it will tell you as well to pin it to the toolbar right here. So when you pin to the toolbar, it's visible. So you can see that when I unpin, it gets invisible. So when I have to pin it back to be able to use it. So hopefully that was clear. So I think I've realized I have my metamask wallet there as well. I'm going to show us the difference between these wallets with metamask and what's the special bit with. Guys, can you try to install your wallets maybe, or maybe you can do it after the session, but that's how you do it. So let me open my metamask right here and I show us the difference in the wallets, the difference between those on Starknet and and the conventional Ethereum. Okay, someone is asking, could you kindly pardon on the procedures for installing? So procedures for installing the wallet as follows. You go to Google and then you put Braavos Chrome extension, because it installs, you add it to Chrome as an extension. Then it will bring you options here. Then you click on the first option. So then it will show, in case you didn't have it before, it will show add to Chrome. But since I already have it, it will show remove from Chrome. Yeah. So it will tell you add to Chrome. Okay, let me remove from Chrome and then we follow it properly. So I'll say here add to Chrome, and then it tells me add extension. So maybe you can now follow along properly. So now it's installing. It has finished installing. So now that it has finished, it's saying Bitcoin and Starknet wallet has been added to Chrome. Yeah. So it opens. Now I have to configure. I don't know whether you guys are following properly. So now I have to configure it. Let me. So it's configuring. So it's telling me create a new wallet or import your seed phrase. So I want to create a new wallet. So in case you already had a wallet, yeah, you don't need to recreate another. So there is something called a seed phrase, just like in your traditional account, yeah, traditional account, there is something you call a pin. And when someone has access to your pin and your ATM card, they can be able to withdraw money. Yeah. So that's the same thing that a seed phrase does. So a seed phrase is all it does is that when someone has a seed phrase, they can actually log into, when someone has a private key, yeah, when someone has a private key, they can actually impersonate you and they become like the actual owners of your wallet. So one of the things to keep seriously is a private key and a seed phrase. So when someone has a seed phrase, they can change, they like, so a seed phrase gives someone to 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 impersonate you. So when you create a wallet on either Braavos or Agent, even on metamask, so there is a 12 keyword which is being given out to you, and this keyword is like, once you forget your password, you have to put that keyword here. So as you can see, they're telling me what is your seed phrase. So in case I had an account before, I don't need to create another one. I just enter here my seed phrase and it will restore my other account. Yeah. So now in case someone has my seed phrase, they will they will be able to have access to my account. So I don't know whether we are following. So now it will tell me create a new wallet, and then I can just add here a new wallet, and then it will tell you whether your password is strong. Let me just create a password here. Now it has created it. Let me re-enter my password here. So guys, in case you have any questions, you can put it in a chat or you can unmute and ask. So now it's creating my, yes, Samson.
Yes, yes, master.
Yes,
Us installing Braavos and then Agent X wallets
yes.
from yeah, using Chrome extension. Are we going to have
Yes,
them
yes.
on our? Are we going to have them on our PCs, so we can have the accounts of what's that?
So, because when you are building a smart contract, you're using a laptop, so you need to have it on your laptop, on your Chrome. Then You only use it on phone if I told you probably have money there and you want to what, to transfer the money from the phone. So you can, for example, agent wallet has a mobile application. So there are cases where you just want to access your wallet using a phone. So but for when you are writing a smart contract, because we need to have access to 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 our wallet, so it's best when you have it on the laptop as well as an extension. So I don't know whether I've answered you properly. Yeah. So that's how you it's taking some good time. So but meanwhile, that's how you install Braavos. That's how you install Agent X. Yeah. So there is a difference between these wallets compared to, so metamask is the let me open metamask right here. Metamask is the commonest wallet used on Ethereum. Let me see if I so let me give us a difference and how account abstraction works in Starknet. So the metamask wallet looks like this as well. So it has ETH. So it's the commonest wallet used for it's the commonest wallet used on Ethereum. Yeah. So so you can, so when you are writing your application and it's still in test mode, you don't need to use mainnet. Means that it's live. You are when you are writing. So after you finished writing your application, you have to host it on mainnet because it has to go to the blockchain. So mainnet, it means now it's live, and once you are using an address from the mainnet, yeah. Remember I told us this is, for example, here this is my wallet address. So you just copy it and use it. But when you are still developing your application and you're testing, yeah, you don't need to use mainnet because mainnet is actual money. You don't need to use mainnet, you need to use testnet. So testnet is just money which is used for testing. You cannot use it to buy anything. Like you cannot exchange it on Binance or what. So hopefully that is clear. So but once you see here that, so this wallet as compared to, so I want you to study this wallet. When you try and compare it to the Braavos wallet, I'm going to cite out some features which are lacking on this wallet in compared to Braavos wallet. So for example, let me go to the settings right here. Okay, just a minute. I want to. So when you say this wallet, is that they've made the Braavos wallet and Starknet wallet in such a way. Where is it? My Braavos. Let me, just a minute. I want to put it back. Extensions. Manage extensions. Details. Pin to toolbar. So let me open my Braavos here. Okay. It's taking quite some time. Let me open it again. So the biggest difference between MetaMask and Braavos and Agent is that Braavos gives you extra security, yeah, as compared to MetaMask. So let me try and open it here. So it opens. It also tells you to reveal your secret key. I can just copy it. I saved my secret key. So now I want us to see this. No, this is the account abstraction. This is the extra layer that I'm talking about. So in comparison to MetaMask, you can see that So the wallets on Starknet, they have added a lot of layers of protection in comparison to MetaMask. The MetaMask, they are only limited to private key and the seed trace, but here they have gone as far as adding 2FA, and then for devices which have biometric, they have added the provision for biometric. So, and I want us to understand that the once your private key is taken away, or once your seed phrase, once a hacker has gotten, or maybe you've, that's why when you need to keep your private key. I've ever lost quite a big sum of money, because someone got, I don't know how they did it, but kinda they got my private key, and they were able to steal money from my wallet. It's been like, I think, 2 months back, and it was a huge sum. So one of the things that you're supposed to play to keep critically, it's your private key and then your seed phrase. Yeah. So, and then I want to advise us that when you are building, yeah, when you are building, for example, in testing, you don't need to use like for example, when you're testing your application, and then what, you don't need to use the you don't need to use, first of all, you are not supposed to reveal. Yeah, never make a mistake of revealing your private key, guys. Your private key is like your pin. When someone has it, your money is gone. Yeah. So the extra layer, as different from wallets like MetaMask, in Starknet, the extra layer, so it the wallets here have two-factor authentication. So that's the account abstraction I'm talking about. So it has 2FA. So you can be able to add, yeah, because for everything to proceed, so for every smart contract to be deployed, so guys, after you've written your smart contract, you have to, let me go back to our slide. So after you've written your smart contract, you have to deploy it on the blockchain. Yeah. And as I said, on the blockchain, you need to use a wallet. You must have a wallet address, because you need to use something to pay gas fees. Yeah. Now the difference is that so on Starknet, there is what we call a signer and an account. Yeah. So I was still talking about the wallet at the wallet. So Braavos, for example, Braavos, we saw that it gives me an option to, right here, it gives me an option to add 2FA. So when I add 2FA, yeah, so this 2FA is, it's like, since this wallet is a signer, so nothing, so every activity which is happening, once I've added, it's so a signer, I want us to understand it as a device. So it can be a phone, it can be your laptop. Yeah. So this signer is a hardware device which is harboring your wallet. Yeah, your wallet address, and the wallet address is found in the wallet. Yeah. So nothing can proceed if at all the signer is not allowable to 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 verify the transaction. And this is different from MetaMask. MetaMask does not work like this. Yeah. So let me go back to my slides. So, and then as well, a signer as the device. So the private key, I talked about the private key. So I think I can show us a private key, because this is a test. This is a test. This is a test account. So even though I show it to us, it doesn't matter. So now everything has been added. So my wallet, I should be able to use my wallet right here. So now this is my wallet right here. So now I want to show us a private key, because this, so are you seeing, guys, here? So this is the critical bit. This is the critical part. So you can, this is your recovery phrase. I said when you lose your when you forget your account or your private key, when you forget your password, this is this you only need a seed phrase. So let me show us a seed phrase, because this is a test account after. So this is how a seed phrase looks like. Is this is a seed phrase. There are 12 keywords, and once you forget your password, so you are required to copy this and store them carefully. So once you forget your password, you will need this to retrieve your account. So then this is a part for the private key. So they're telling you never disclose this key, but I know this is a text account because I have no money on it, so I can always open up another one. So private key is this, yeah. And if at all I'm to compare, so I want us to look at an example like of how Gmail works. So in Gmail, if at all you've forgotten your password, yeah, they will tell you forgot your password. Now maybe they'll send you, they'll send a notification on the security device that you added, and they will tell you to verify whether it's you. Then after that, they will give you a provision of getting a new password. Yeah. But then on 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 Braavos or on these wallets on Starknet and on blockchain, once you have lost this private key of yours, yeah, once and someone has this private key, they can actually impersonate you. Yeah, there's no provision where so unless, so now this is where the 2FA, the extra layer of account protection comes in. That if you've added 2FA, for example, 2FA, you can add an email, you can add maybe your app. For example, Braavos has an app. So for every transaction, for every activity that you make, the app has to be in sync with this Chrome extension. So even though someone has my private key, yeah, the the extension has to send this person to verify it on the app. So that's why it's very important to add 2FA. So I've talked a lot about wallets. I don't know whether there is any question about that, because we are soon actually ending. Any questions around wallet? Because yeah, so let me finish up. So our account holds the assets, and then assets in this case are STRK. And I said our account, in this case, the wallet, it verifies the signatures. So any questions, guys? We've shared a lot. We've looked at a lot of concepts here. Any questions? Any questions that you have, you can write it in the chat or you can ask. Any questions, guys? We've talked we've talked about a lot of things here, and at least someone must be having questions. Anything that you want me maybe to explain, or maybe something that you didn't get properly? Yes?
Yes, master.
Yes, anything
Yes,
that you want
master.
me to rectify? Yes, yes.
Yes, master.
Yes, I
I'm
can hear
saying,
you. Yeah. Please go
okay,
ahead.
master.
Go ahead, please.
Now,
Okay, so the recording should be available by tomorrow for the first session. So it will be uploaded, and I'll share the link in the group. So they are working on the recording, and it should be available. Yeah, there is. I understand if at all you didn't, you either you turned up a bit late for the first session, there is a way it tends to confuse a little bit, but the recording is gonna be uploaded, so don't worry about that. So any other questions, guys? Anything that you would want me to clarify? We're supposed to end at we're supposed to end our sessions at 10, and I say it's already 10. So guys, any questions? And yeah, I think I shared the slides in the group. I shared it in the group. Any question? You can either unmute and ask, or you can share it in the chat. Well, I think guys are content with whatever that you shared. Thank you so much, guys, for being part of session 2. Our session 3 is going to happen next Tuesday. Remember, our sessions happen twice a week, same time. And yeah, all the 2 sessions are going to be available before the end of this week, probably before Friday ends, so before tomorrow ends. So you should be able to catch along, and in case you have any questions, you can always share them in the group. And yeah, so in case there is no any further queries, we can call it a night. And thank you so much, guys, for turning up. And I believe we are gonna achieve a lot. Thank you so much, and have a good night. Have a good day.